Okay, now I'm going to use this, I don't know where that chalk went. I'm going to use this small space here to just kind of do in front of you what I'm going to point to here. So if we have a point, and we'll call that point x1, y1, and a line through that point with slope m, we want to find the equation of this line, which means that we want to find how a point xy on the line, how x and y are related for point xy on the line. So we simply say, okay, well, we got fundamental triangle here. The rise is y2 minus y1. The run is x2 minus x1. So the slope is y2 minus y. Sorry, it's not y2 minus y1. This is xy. So the rise is y minus y1. Okay, y minus y1. And the reason we use y here instead of like a y2 is that y is variable. This point could be anywhere on the line. So this xy stands for an infinite number of points. And it's a relationship that can be used to relate the x and y values for any of those infinite number of points. So the slope is going to be y minus y1 divided by x minus x1. Now the slope is m. So our y2 minus y1, so our y minus y1 over x minus x1 has to equal m. So that if we have a line through the point x1, y1 with the slope m, then if xy is on the line, y minus y1 over x minus x1 has to equal m, whatever m happens to be. Now down here we say, okay, we do a line through negative 5, 7 with a slope of negative 3. So we could write away. We could plug in negative 5 for x1, 7 for y1, and negative 3 for m. We could then solve this equation for y, and we would have the slope-intercept form of the equation. Now instead, what we do, we run through all the same reasoning, and we get y minus y1 over x minus x1 equals m. Okay, so then we solve this for y. Now, I didn't actually end up solving it for y. I stopped at this point, and I'll show you why. I'll explain why I did that. But to begin solving this for y, we multiply both sides by the denominator. We have a fraction equal to something. If we multiply both sides by the denominator of that fraction, that clears out the denominator and gives us a result that we can use. Okay, so we multiply by the denominator x minus x1. Now we should understand fractions, and of course this was reviewed, or this was done very first thing in the course. You might need to review that if some of this doesn't make sense. But x minus x1 multiplied by y minus y1 over x minus x1 is the same as x minus x1 divided by x minus x1 multiplied by y minus y1. And x minus x1 divided by x minus x1 is what? Well, if you divide a quantity by itself, as I said in class, what's 7 divided by 7? Everybody says 1. What's 596 divided by 596? Everybody says it's 1. And it is. Well, what's x minus x1 divided by x minus x1? It's 1, as long as x minus x1 isn't 0. Can't divide, 0 divided by 0 is not a defined quantity because you can never divide by 0. Okay, but in the absence of x being equal to x1, x minus x1 divided by x minus x1 is 1, and 1 times the quantity y minus y1 is just y minus y1. Now we multiply by x minus x1 on both sides. On this side we get x minus x1 times m, which I turn around to m times x minus x1. Multiplication being commutative, we can do this. So we end up with y minus y1 equals m times x minus x1. you will see this in your textbook as the point-slope form for a straight line with slope m through the point x1, y1. So this is point-slope form for a straight line. Now, we did something else in class before we did this, but I'm going to stick with this, and we'll just do this example. Line through -5, 7 with slope -3. Well, we identify -5, 7 as the point that we know. Okay? As I labeled it up here, and the labeling is a little more complete up here, x1 and y1 is the given point. These are given values of x1 and y1. Okay? xy is any point on the line, as I've mentioned here, but we wrote it out here. And what we're looking at is a situation where we're given one point, which we call x1, y1, because we don't have the numbers. This could stand for any two numbers. And slope, given one point and the slope, well, the slope we're going to call m. Okay, again, then we get this, which reduces to this. Now we're just going to use this. Now, as I said, you have a couple of options when you get to a test and have to do this. You can memorize this formula and learn to plug the numbers in. Or you can learn to draw the picture that I started with, just the point with a line through it, slope m, the point is x1, y1, and this point is xy, and then you proceed to get this, which you simplify to this. And I asked the people who were present today, everybody said, there weren't that many people, so it's not a large group, but everybody said, rather than having to memorize this, they can work better from knowing how to draw the picture and use the fundamental triangle. So the reason I'm emphasizing the geometry in the fundamental triangle is simply that I observe that students, as a general rule, and of course there are exceptions, but as a general rule, students have a great deal of trouble memorizing anything. Also, if you memorize it, you're going to forget it a lot quicker than you'll forget the picture. Once the picture makes sense to you, it is likely to stick with you, and your knowledge will be much more secure. However, there's no penalty for not being able to do the picture to get this. So if you memorize this correctly, okay. If you memorize it and don't use it right, or memorize it wrong, well, I can't give you much credit for that, can I? Okay. So you decide which is more secure for you. Optimally, you do it both ways, but everybody has a finite amount of time and attention. Okay, well, now that we've derived this as a formula, we can use it. And my advice to people is, if the picture makes more sense to you than memorizing, be able to draw the picture and derive this expression first thing when you start taking the test. There's no time limit in the test. You have time to do that if you want. Okay, you could start with the picture, get this, and then use it. Alternatively, you can always do the picture with the coordinates and stuff, and we've done that. It's the first thing we did. Okay, so, again, we identify -5, 7 as our x1, y1, so x1 is -5. We're going to replace x1 by -5. And we're going to replace y1 by 7, and we're going to replace m by -3, since the slope is said to be -3. And we get this. Literally, y minus 7 equals -3 times x minus -5. Just direct substitution. I don't do the minus to get the plus until the next step. So in the next step, we do the minus 5 to get x plus 5. And then we add 7 to both sides, and we solve for y. Okay, and here's our solution. Now, this isn't simplified. To simplify it, we've got to use the distributive law to multiply through here. And literally, -3 times x plus 5 is -3 times x plus -3 times 5. And we still have our plus 7 out here. Of course, plus a -3 times 5 is plus a -15, which is just -15. So we get -3x minus 15 plus 7, which simplifies to -3x minus 8. This is slope-intercept form. It's the y equals mx plus b, probably the most standard form of the equation of a straight line. There's the intercept form of the equation as well, but to keep things simple, we'll just for now, talk about the slope-intercept form. M is the slope, B is the y-intercept. So, the slope of this line is -3, and that's as it should be. And the y-intercept turns out to be -8, meaning that the graph crosses the y-axis 8 units below the origin. Okay, well, that's pretty much what we can do if we want to get the line through a given point with a given slope. Now from this, of course, we can calculate our intercepts and all sorts of things, but we've done that elsewhere.